Everybody, video number 7, classification of matter. When you are done with this video, you will be able to figure out the difference between elements, compounds, and also some insight into pure substances and mixtures. Okay, we will get into them again deeper later on in the year, but let's get a nice overview going forward. You're going to be able to do the POGL when you are done with this. So you need to understand first that atoms are represented by single spheres. So I can color them all in, or I can leave them hollow, right? Or I can decorate them in any kind of way I'd like, but any of the ones that are filled in all black are the same. Any that are left clear are the same. Any with an X are the same. Lines are the same, okay? I can have a molecule of elements. Molecule of elements are two or more of the same size and color spheres joined together. So we call this a diatomic element. So you need to understand that particular picture is an element because notice same size, same color. Okay, but a compound, by definition, will be represented by two or more spheres of different size and color joined together. So, in other words, I need two different atoms together to form a compound. By definition, whoopsies, went too fast, folks. So it should look like that. Now, granted, I didn't make them different sizes, so the size they just have to be different in some way. So one's clear, one's colored in solid black. One could have a stripe, one could have a circle in the middle. One could be big, one could be small. I need to be able to differentiate them in some way, so it doesn't have to be different size and color. Different size or color is a better way to say that. Okay. Now we get into pure substances and particle diagrams. So we started with the particles themselves. Now we're just going to put them in a box. Okay, so a picture of particles helps us distinguish atoms from molecules. Okay, and a substance that is the same throughout is a pure substance. I can have a compound like water, H2O, and then I can have nothing in my glass but water. And that would be a pure substance. So compounds can form pure things. I don't want you to think because there's different elements in a compound that I can't have a pure sample of that compound. Okay, so nuances in the words are big in this course, I promise, unfortunately. So monatomic element. Mono means one, so that means my atoms are going to be separated into single spheres. Okay. Diatomic. Di means two. So I'm going to have something very similar, except for they all need to be hooked up into molecules. Okay. And they all have to be the same. So this is a diatomic element. I know it's an element because same size, same color in my particle diagram. Okay. Then a compound, and this is all pure, by the way, because we're in the pure substances section. Now I can have a pure compound because if you notice, they're all the same compound with one black and one white. But they can rotate around in space. You can imagine if you're pouring a glass of water, the molecules are going to be tumbling. So they don't have to be in the same left and right fashion, but they need to be the same consistency. One not colored in, one completely colored in. That way I know that this sample is pure and it's made up of a compound. Okay. Then we can get into what we call mixtures. So if I take two or more different things and put them together, it does not look the same throughout. So that's a dictionary scientific type definition of this. So you think of sand and water. You shake it up, it's going to get kind of murky all the way through, and you set it down, and all of a sudden the sand's all going to fall to the bottom. You're going to see sand, you're going to be able to see water. If I can see two different things, it's going to be not just a mixture, but it'll be what's called a heterogeneous mixture. Okay? So here is a mixture of compounds. I have two different compounds. Okay, one is a black sphere and one's a striped sphere, and the other one's a black sphere and a clear sphere. Okay, and I can have a mixture of monatomic elements. These are all going to be single spheres, but they need to have different colors. So this is two different elements mixture. Okay, this would probably be heterogeneous. And then we get into phases of matter, and this is kind of important too. I draw these pretty much the same all the time. So same substance can exist as a solid, liquid, or gas depending on the energy present. We'll get into that later and transferring from one to the other. We can differentiate how we draw them in their arrangement because we know by definition solids are like rigid. Whoopsies. Here we go. Touching and locked in position. Locked in position is rigid, is the word I would normally use. It does not take the shape of the container. It does not take the volume of the container. You have to kind of space that in as best as you can into the room you have. I think I gave you a lot more room this year than I gave kids last year, but it's still going to be an issue because you notice how the way I had to write it in there kind of comes under liquid. So hopefully you got a little bit more room and you can get everything in here written you need. But notice my spheres are touching. They're on the bottom and they're not touching the edges or the walls of the container. You drop a penny in a cup. Does the penny touch all the sides of the cup? No, not unless you start shaking it. Okay. Liquids, on the other hand, will take the shape of their container. Notice they are touching the side walls. So they're touching, but they can move. So a lot of times what I do when I draw these by hand is I overlap them a little bit so that you can see that they're allowed to move, but I make sure that they're touching the sides because by rule, I will take the shape of the container, but it does not take the volume of the container. If I have a half a cup of coffee, I know the liquid's only here. You probably can't see this almost full cup of coffee, but it's not completely full. It doesn't take all of the volume of the container up. Okay, and then gases by rule. Ta-da! I always start with one touching all four sides at minimum when I'm drawing these things in because by rule, they are not touching. They can move around, but they does take the shape of the container and it does take up the volume of the container. So I like to make sure in my box I start with one on every side to show that it takes up the volume of the container. And now we understand how to draw solids, liquids, and gases. We got into single atoms, diatomic atoms, and compounds, and the difference between mixtures and pure substances. And if something is lost on you after doing this, guess what? We have practice to do, and then we do have the POGIL to do, which if I didn't clear everything up here, and maybe I created some confusion by accident, that'll straighten it all out, and you'll be all set and on your way. And, oh, we're not done yet? I thought we were done. Okay, so this is a breakdown. This used to be in the you do section, but some of the wording was a little funny. So you have to kind of go backwards on some of this. So by definition, cannot be separated by physical means. That is the definition of an element or a pure substance. Okay. And can be separated by physical means is what we call a mixture. So then we go down again to can't be separated by chemical means. Oh, that's the difference. Physical means and chemical means. By definition, cannot be broken down chemically is an element. And so if I were to draw an element, I'm going to do compound first. Separated by chemical means only. Okay, so I can separate by chemical means. Hit water with electricity, I can break it apart into hydrogen and oxygen. Particle diagram of an element. I decided to make a diatomic particle diagram of an element just to reinforce that diatomic elements exist. We will get into them more specifically later. And then a compound that is pure means all of the same compound within there. Okay, good? Good. Now we're going to get into mixtures. So same composition throughout is what we call a homogeneous mixture. Homogeneous means same. Homo means same. So if I'm the same throughout, can't see any difference between the top and the bottom. I set it down, it doesn't settle out. It's a homogeneous mixture. True solution. If I see differences throughout it, like Italian dressing, there's all sorts of different colored small particles in Italian dressing, that would be heterogeneous. I can see different things. So particle diagram of a homogeneous mixture, okay, is two things. I put in the water and I put in the element. Okay. And then a heterogeneous mixture is water with different things, and I'm going to be able to see them. Okay. Ooh, I should have mixed those up a little bit, but I think I did it like that so you can see that they usually layer out a little bit if they're heterogeneous. Okay. So now I think with that, we are maybe, oh, see, there you go. Settles out. Nice. Nice. Can you tell it's early in the morning, by the way? I need a cup of coffee. But yes, we finally finished. So there you go. You got practice to do after you doing these notes. You got a POGIL, and you should be all set. And I'll see you guys in class today.